Thanks, Joy, and thanks to the conference for hosting the session. Also, thanks to my family who we have flown in from Brisbane just to give this presentation. That's my wife and daughter there showing their support. So my name is Nicholas Heyer. I am currently a PhD student at Griffith University at the city's Research Institute, and my dissertation topic revolves around the major positive frameworks for the legacy infrastructure that will be developed for and delivered for the Brisbane 2032 Olympics. I'm also a certified biomimicry professional, and I'm here on behalf of the Born Global Foundation, which is a educational not-for-profit that does bio-inspired and nature-based design solutions in education at multiple levels for entrepreneurship and innovation and education. So, for context too, I'm just about at my first milestone in PhD. So literature reviews are very fresh in my mind, and looking at the the call for abstracts for this session, that was my immediate reflex response, was to immediately dive in deep into the literature review and try to figure out what might be interesting and useful to say about biomimicry. And I think the bottom line to all of it, especially for everybody here at this conference, the people working in the biodiversity sciences, biologists, ecologists, conservation scientists, etc., is you matter, you're important. The work that is here represented at this conference is each of it just a morsel of and a component of that pathway that leads us to a regenerative future. And if you're ever stuck for something, always look for a quote. There was somebody, a poet, that's more eloquent than me. In this case, this is my superhero, Edward Wilson. The challenge that I'd like to address in this presentation is how do we align the human needs for sustainable urban development with life's needs for a world living in harmony with nature. And a world living in harmony with nature is from the 2050 vision of the Global Biodiversity Framework. And when I pulled out some of these needs, right, this is from the 2030 agenda in reference to SDG 11. These are our human needs for urban development. And then here's relevant to the built environment from the Global Biodiversity Framework on the right. Some of these match and they're aligned. We want to create green spaces, make them accessible, make them beautiful, make them places that people can interact with nature. But we also have this problem that our population is growing, our resource consumption is not slowing down. And that is directly at odds with many of these goals in that 30 for 30 and the Global Biodiversity Framework. And reconciling that is something that I will spend the rest of my life researching and developing technologies and innovations to advance that agenda. What I know from the literature review is that the solutions will require innovation, collaboration across disciplines, and a reconnection with nature. I think that last part is, to me, the most important. We have this innate sense about us as we walk through our lives and shuffle along this mortal coil that is we're human, but we're also part of nature. And then there's this other part of us that wants to put nature separate. And I believe, and I choose to believe, that the urban environments and sustainable development of our urban environments don't have to be at odds with that. They can reconcile that through the design and the structures. But referencing to innovation specifically, this is from a piece called Mainstreaming of Biodiversity in the Infrastructure Sectors from the Conference of Parties on Biological Diversity. Right? These are the needs. These are just some of the needs, some of the priority needs that we don't have solutions for. And we need to develop innovation around. We need technology and processes to achieve these. Right? And so to the first question that was in the session that you posted there, Joy, in the call for abstracts, how does biodiversity support innovation? And conversely, how can biomimicry support biodiversity? And my answer to that is that biomimicry drives innovation and interdisciplinary collaboration and reconnection with nature in our urban environments. And when I'm talking about innovation and interdisciplinary collaboration and reconnection, just a little bit of context. Last year I was very fortunate. I got to go out and help out with a research center being stood up at the University of Oslo. And this research center is called INTED. It's the Center for Interdisciplinary Education and Research. And what they're trying to discern is answering these calls from industry and recognizing the growth of interdisciplinary programs in universities worldwide here in this recent era, and understand this context, this global planetary crises and the nexus of crises that are within it and the systems of systems. These are wicked challenges, and it can't be solved by one discipline alone. What was really, really fascinating about helping to work on this research project, where they want to put students first and they want to have students lead each other from different disciplines within this institution to create interdisciplinary or generate interdisciplinary competencies and skills, was a lot of the skills and competencies, the goals of interdisciplinary education from the research and in the literature, and it revolves around the skills that are in the curricula of kindergarten, right? Effective skills. How do we get along? How do we listen to each other? How do we identify ideas and validate them and evaluate them? And what does that look like in practice? And there's a curious lack of syllabi that looks like kindergarten curricula in the rest of our educational systems. That was my foot-stomp key takeaway from working there. All right, moving on to the big question. You're all sitting in here, you're interested in the topic of biomimicry. So what is it? And what does it consist of? And we get this a lot. Every time that I walk into a room and I start talking about biomimicry, I write it in an abstract, I'm immediately told that I have to define it and define it in a way that maybe my local barkeep can understand and we can have a conversation about. So this is the definition that comes out of the Biomimicry Resource Handbook. It's probably the most widely circulated amongst the practitioners from our intellectual heritage, which is via the Masters of Science program that's hosted at Arizona State University. And but there's another important definition too that I want to touch on, and that is included in the ISO standards. There's an entire standard that defines biomimetics and biomimicry and bioinspired and all the key terms and definitions, right? And what that says is that biomimicry is a philosophy and interdisciplinary design approach that takes nature as a model to meet the challenges of sustainable development, social, environmental, and economic. And it reemphasizes that in the definition of biomimetics, which is slightly different. Biomimetics is more of the European intellectual heritage, where sustainability is kind of built more into the technological fabric of social structure. And it also says interdisciplinary cooperation with biology and technology or other fields of innovation with the goal of solving practical problems through the function analysis of biological systems. So those key definitions, I think, are really important to me because it helps me to understand what is this field. When I'm answering that question, I get that puzzled look from my local barkeep about what it is that we're doing. But really what we're doing is something that's a very innate human and ancient practice, which is just looking at the world around us, using these big, heavy brains of ours to observe what's going on and figure out a way to make use of that information through our technology. And to our knowledge, we're the only species that's doing that, and it's caused us a lot of problems, so I'm hoping that biomimicry helps us resolve that. To your next question, Joy, how can biomimicry increase the value of species diversity and conservation efforts? The first thing that I want to say is that in the practice of biomimicry, we're going to look across the entire field, as Rolf has said. We're going to look across taxa, and we're going to look across what has been written, because we're going to take a function. right? This is in the top-down approach where we're taking a design challenge to biology. And we're going to see what in nature, in the living world, is already solving for this challenge that we're trying to solve for with engineering. And what's really important is not just, because we often tell the story, and you hear stories when you see biomimicry in the news, and it'll be one through line where this one champion organism is responsible for solely inspiring this technology, but the truth is, biodiversity is solving it, right? There are organisms across the entire tree of life that are solving for the same challenge, and the way that they are solving for those challenges and teasing out the deep patterns, that's where the value is. And that's why biological diversity conservation and species richness is so important, because every single one of these species contains a massive amount of information that are these little, future industry secrets, unfortunately proprietary, right? Whatever, it doesn't matter because they've already figured it out and they've validated it, not just longitudinally across 3.84 billion years of evolution, but laterally across taxa. And I think that's really important. I'm going to give 3 quick examples of built environment examples for biomimicry, and of course these in the publishing, in the research, each of these examples identifies one specific species, but again, ask yourself, how many other species are solving, and where are they the same, and where are they different when they're solving for these functional challenges? For example, here we're talking about lobsters. But all arthropods have this helicoidal structure, not all, but many of them have this helicoidal structure, and they have these little strategies and mechanisms, right? So the lobster claw and the lobster shell is basically a very complex copolymer or laminated polymer that also uses chitin protein strands of fibrils to reinforce it, and that makes it extraordinarily resilient and durable. And for a number of years, researchers have been, it's not just this group from RMIT, but a few others that have been trying to adopt this to 3D printing for concrete. And one of the challenges is that 3D printers will go in like one direction, and then you have to wait, and then it'll come back, and we print again, and maybe we can cross-laminate the sections the way that we know how to do this simply in engineering. That's not what nature is doing. Nature is building a much more complex structure, and it adds, when we replicate this using the same technology that already exists with 3D additive manufacturing for concrete, it produces a much more resilient and extraordinarily stronger, both compressive and fleshable strengths. Right? Outperforms anything else on the market. Here's another one. This one is pine cones. And what's interesting about pine cones, again, another complex copolymer material, but in this case, it has at least two distinct layers, and they're both sensitive to the humidity in the environment. So as the humidity goes up, then the pine cone stays closed and seeds stay protected. As the humidity goes down, the pine cone desiccates, it opens up automatically. So this is remarkable for engineers, because this is a coupling of sensors and actuators. And we can use this in building facades to have complex and dynamic building envelope skins that would reduce our load for HVAC, heating and cooling systems, and also create more energy efficient buildings. And this last one, this is at a systems level, because everything exists within systems and systems, and this is a current theme and a very strong theme in biodiversity conservation work, right? The ecological side, where does that individual species fit? And what this one is really referencing is the work of Biomimicry 3.8 with the interface carpet manufacturers out of LaGrange, Georgia, in the United States. And they asked the question to Biomimicry 3.8, who's an industry consulting firm in the US, how would we create our factory to function like a forest? And what they did was they set a reference baseline for what the forest would look like if it were ecologically intact for that local biome. They took ecological performance metrics from what that baseline would be, and they made a strategic plan to approach through the operations of their factory that or exceed what would be the ecological services and the functions and performance measures if that ecosystem were intact. And so this factory then in place actually is contributing a positive impact to its environment. And this can be replicated. So the final question that you asked, and I know I'm just about out of time, how can biologists support biomimicry solutions? And I thought about this one a lot. And here's what the literature says, right? And also what I say, right, based off of what the literature I wrote. You take a picture of this slide, but the point is, the way that you communicate, and I understand now, dipping my toes into this research world and science world, that we have this struggle when we're, especially with editors and trying to get our work published and communicated. But know that there's a group of us out there that are looking to solve these wicked challenges, and we're looking to the stuff that you are putting out, the communications and the work that you're doing. And it can be very challenging, especially if we don't have a solid background in biology. So writing and communicating in a way is very important. The other thing that I would say is showing up to the design table. You have a place there, whether it's recognized or not, and you contribute value there. The farther away that the target domain is where we're creating the innovation, the higher that value is. And the more complex of the solution that is needed at like systems level, the greater the impact you will have. Those are my key takeaways. Thank you.